In the early hours of November 1st, 2025, astronomers around the world turned their telescopes toward a patch of sky where nothing should have been visible. For weeks, 3I Atlas, the third confirmed visitor from beyond our solar system, had been hidden behind the blazing disk of our sun. The scientific community held its breath, waiting for this mysterious object to emerge from the solar glare. When it finally did, what they witnessed left them stunned. What you're about to discover challenges everything we thought we understood about objects from interstellar space. This isn't just another space rock drifting through our cosmic neighborhood. This is something that has forced NASA to make decisions that are raising uncomfortable questions throughout the scientific community. Before we dive into what happened when 3I Atlas reappeared, let me ask you something crucial. If you discovered evidence that could reshape our understanding of what exists beyond our solar system, would you share it immediately with the world? Or would you hold it back, carefully controlling how and when that information reaches the public? NASA made their choice, and that choice is creating a storm of controversy among scientists who believe the public deserves to know what was really observed. Here's what we know for certain. On October 2nd and 3rd, 2025, as 3I Atlas passed within just 29 million kilometers of Mars, something unprecedented occurred. NASA's Mars Reconnaissance Orbiter, equipped with the most powerful camera ever pointed at an interstellar visitor, captured images that should have answered fundamental questions about this enigmatic object. Images taken from a unique side angle that could reveal structural details invisible from Earth-based observations. Images with resolution 3 times sharper than anything the Hubble Space Telescope had managed to capture. Those images were taken over 40 days ago. As of today, November 15th, 2025, they remain locked away in NASA databases, classified under a designation that requires special approval for release. No scientific journal has published them, no research team has analysed them. The global astronomical community continues to operate with incomplete data about one of the most significant discoveries in modern space science. Think about the implications here. We're not talking about routine Mars geology photos or standard atmospheric measurements. We're discussing the clearest images ever captured of an object that originated from another star system. An object that has been displaying behaviours so unusual that they're forcing scientists to question fundamental assumptions about how matter behaves in interstellar space. Harvard professor Avi Loeb, one of the world's leading experts on interstellar objects, has been publicly demanding the release of these images. His frustration is evident and completely understandable. Science thrives on open data sharing, collaborative analysis, and transparent peer review. When crucial observations are held back, the entire scientific process breaks down. The official explanation keeps shifting like sand beneath our feet. Initially, NASA cited a government shutdown as the reason for the delay. That shutdown ended days ago, yet the images remain unreleased. Then came vague references to bureaucratic processing requirements and internal review protocols. But here's what makes this situation even more suspicious. NASA's high-resolution imaging system continues to release new pictures of Mars every single day. Routine geological surveys, crater formations, atmospheric phenomena, all flowing freely to public databases. Yet when it comes to 3I Atlas, there's suddenly a special protocol in place. If you're finding this as concerning as I am, make sure to subscribe and hit that notification bell. What I'm about to reveal about 3I Atlas itself will explain exactly why these images might be so sensitive that NASA feels compelled to control their release. Let's step back and understand what makes 3I Atlas extraordinary in the first place. This isn't simply another comet wandering through space. Since its discovery by the Atlas Survey Telescope in Chile on July 1st, 2025, this object has been rewriting the textbook on how interstellar visitors should behave. We've only confirmed 3 objects from beyond our solar system. The first was Oumuamua in 2017, that bizarre cigar-shaped visitor that sparked years of scientific debate. The second was 2I Borisov in 2019, which behaved exactly like astronomers expected a normal comet to behave. Then came 3I Atlas, and from the moment telescopes locked onto it, something felt fundamentally different. The Hubble Space Telescope captured the first detailed images back in July, and what those pictures revealed immediately caught the attention of researchers worldwide. Instead of the typical comet tail streaming away from the sun, pushed outward by solar radiation pressure, there was something else entirely. A structure extending toward the Sun, an anti-tail that defied the basic physics of how solar wind and radiation should affect small objects in space. Now, anti-tails aren't completely unknown in comet science. Under very specific geometric conditions, when viewing angles align just right, dust particles can create the optical illusion of a tail pointing sunward. But what Hubble observed wasn't an illusion. The viewing angle was nearly edge-on, just 10 degrees off the Sun's direction relative to 3I Atlas. This was a real physical structure extending toward our star, against every force that should be pushing material away. This is where the story becomes truly fascinating. On October 29, 2025, 3I Atlas reached perihelion, its closest approach to the Sun at about 130 million miles away, just inside Mars' orbit. This is the moment when comets typically put on their most spectacular displays. Solar heating causes surface ice to sublimate into gas, creating brilliant tails and sometimes causing complete fragmentation. Scientists worldwide had their most sensitive instruments trained on 3I Atlas, waiting to see how this interstellar visitor would respond to intense solar heating. What they witnessed was unlike anything in the astronomical record. Instead of fragmenting or following predictable comet behavior, 3I Atlas underwent a complete transformation. When the object emerged from behind the Sun's glare in early November, it wasn't the same entity that had disappeared weeks earlier. The single anti-tail structure had evolved into something far more complex. Multiple jets, at least 7 distinct streams of material, were now extending from the object in various directions. Some pointing away from the Sun as expected, others continuing to point toward it in defiance of solar physics. But the most startling discovery was yet to come. Surrounding all of these jet structures was a massive glowing halo extending outward for over 500,000 kilometers. To put that in perspective, that's roughly the distance from Earth to the Moon. This wasn't a diffuse cloud of scattered particles. This was a coherent structure maintaining its shape across distances that should have caused any normal gas or dust emission to dissipate completely. Images released by astronomers Jurger, Raymond and Prosperi on November the 9th showed the full extent of this transformation. Multiple distinct jets, each maintaining its individual character rather than blending into a chaotic cloud. The level of organization was unprecedented. Natural comet outgassing typically creates irregular, turbulent plumes that change rapidly as the object rotates, and different surface areas are exposed to sunlight. What 3I Atlas displayed was different, structured, systematic, almost engineered in its precision. 2 days later, additional observations by Frank Nebling and Michael Benner confirmed the same phenomenon from different viewing angles. 2 prominent anti-solar jets heading directly toward the Sun, one larger tail extending in the opposite direction, all part of an intricate geometric pattern that seemed to maintain its stability across multiple observation periods. The Virtual Telescope project, under the direction of Gianluca Massi, began releasing time-lapse sequences showing the evolution of these structures, and here's what made astronomers around the world take notice. The tail system wasn't just maintaining its form, it was growing, measurably extending further into space with each passing day. This behavior violates everything we understand about comet physics. When ice sublimates from a comet's surface, the resulting gas expands rapidly in all directions. Solar radiation pressure then pushes this material outward, creating the familiar tail that always points away from the Sun. The process is chaotic, turbulent, and highly dependent on the irregular shape and composition of the comet's nucleus. But 3I Atlas was displaying something entirely different. Multiple coherent streams of material, each maintaining its distinct trajectory over distances of millions of kilometers. The level of collimation, the technical term for how focused and beam-like these structures appeared, was extraordinary. Think about this for a moment. Imagine heating an irregularly shaped ice cube. As it melts, water would run off in all directions, following the contours of the surface, creating random streams that quickly merge and disperse. Now imagine that same ice cube producing 7 distinct parallel streams of water, each one maintaining its direction and intensity for hours. That would be impossible without some kind of internal structure channeling the flow. That's essentially what astronomers were observing with 3I Atlas. Not the chaotic outgassing expected from a natural comet, but organized, directed streams of material that suggested either a very unusual internal structure or something else entirely. The implications were staggering enough that research teams began conducting spectroscopic analysis to determine exactly what materials were being ejected. If these were natural comet jets, they should contain the typical mixture of water vapor, carbon monoxide, dust particles, and other volatiles common in icy bodies formed in the outer regions of star systems. What they found added another layer to the mystery. On October 24th, just 5 days before perihelion, the Meerkat Radio Telescope Array in South Africa detected something that had never before been observed from 3I Atlas. Radio emissions at a very specific frequency, 1.665 to 1.667 GHz. For those not deeply familiar with radio astronomy, this frequency range is extraordinarily significant. It corresponds to hydroxyl radical emissions, molecules consisting of one oxygen atom bonded to one hydrogen atom. These molecules are a natural byproduct when water ice breaks down under intense solar radiation. But here's what made this detection remarkable. This frequency sits right in the middle of what astronomers call the water hole, a relatively quiet region of the radio spectrum between the hydrogen line at 1.42 GHz and the hydroxyl line at 1.67 GHz. This narrow band has long been considered one of the most promising frequencies for detecting signals from technological civilizations because it's naturally free from cosmic background noise. The timing of this radio detection was perfect for a comet experiencing maximum solar heating. The frequency matched exactly what hydroxyl radicals should produce. By every conventional measure, this appeared to be natural outgassing from an icy body responding to solar proximity. Yet questions remained. This was the first radio signal ever detected from 3I Atlas since its discovery months earlier. For an object that had been under almost constant observation, the sudden appearance of radio emissions precisely during the perihelion window raised eyebrows among researchers who had been tracking its unusual behavior patterns. The detection confirmed that 3I Atlas contained water ice and was actively shedding material during its closest solar approach. But it also demonstrated that whatever processes were occurring within this object were far more complex and energetic than initially anticipated. As these revelations were emerging, another piece of the puzzle fell into place. Analysis of 3I Atlas's trajectory revealed something that shouldn't be possible for a passive object following purely gravitational forces. The visitor was showing signs of non-gravitational acceleration. This means that something beyond the Sun's gravity and the natural orbital mechanics was affecting the object's path through space. Small but measurable changes in velocity that couldn't be explained by conventional comet outgassing alone. MET outgassing alone. When comets experience acceleration beyond gravitational forces, it's typically attributed to the rocket effect. As ice vaporizes from the surface, the expanding gas creates thrust, subtly pushing the object off its predicted trajectory. This phenomenon is well documented and completely natural. But the magnitude and timing of the acceleration detected in 3I Atlas raised questions that conventional outgassing models struggle to answer. The acceleration wasn't random or chaotic as you'd expect from irregular jets firing in different directions as the object rotated. Instead, it appeared coordinated, almost deliberate in its timing and direction. The forces were acting precisely when they would be most effective for trajectory adjustment, during the period of maximum solar heating, when any course corrections would be masked by expected comet activity. This is where those missing Mars Reconnaissance Orbiter images become absolutely critical. The high-resolution camera captured 3I Atlas from a side angle that would reveal the three-dimensional structure of these jets. Were they emerging from random locations on an irregular nucleus as natural comet vents should? Or was there a pattern, a geometric arrangement that might explain the coordinated nature of the acceleration? Without those images, scientists are left to piece together the puzzle using incomplete data from telescopes hundreds of millions of kilometers away. It's like trying to understand the architecture of a building by looking at it through fog from across a valley. You can make out general shapes, but the crucial details that would definitively answer your questions remain frustratingly out of reach. The frustration in the scientific community is palpable. Dr. Loeb has been particularly vocal about the need for transparency. In his words, science should not be held hostage by bureaucracy. These observations are time-sensitive. Every day that passes without access to the complete data set is a day when follow-up observations could be planned, international collaborations could be coordinated, and our understanding of this unprecedented visitor could be advanced. But NASA's silence continues. The agency that once proudly declared its commitment to open scientific inquiry now finds itself in the uncomfortable position of withholding potentially groundbreaking observations from the very community it was created to serve. Meanwhile, 3i Atlas continues its outbound journey, growing dimmer with each passing day. The window for detailed spectroscopic analysis is rapidly closing. Soon, the object will be too faint for precise velocity measurements of those mysterious jets. The opportunity to determine whether they're moving at the slow speeds expected from natural sublimation or at the much higher velocities that would indicate something else entirely is slipping away. This brings us to another crucial aspect of the 3i Atlas mystery that deserves careful examination. The object's behavior during and after perihelion wasn't just unusual, it was transformative in ways that challenge our fundamental understanding of how interstellar visitors should respond to solar proximity. When 3i Atlas disappeared behind the sun's glare in late October, it was displaying that single anti-tail structure captured by Hubble. Unusual, certainly, but not beyond the realm of natural explanation given the right viewing geometry and surface conditions. What emerged in November was something entirely different. The transformation wasn't gradual or evolutionary as you might expect from natural thermal processes. It was dramatic and comprehensive. Multiple new jet structures had appeared, each with distinct characteristics and orientations. The massive halo had formed, extending to distances that should have been impossible to maintain without some form of active containment or focusing mechanism. Most remarkably, these new structures weren't chaotic or randomly distributed. They displayed a level of organization and symmetry that natural outgassing processes rarely achieve. The jets maintained their individual identities rather than blending into a uniform cloud. They extended in specific directions with remarkable consistency across multiple observation periods. This level of structural coherence across such vast distances suggests either an internal architecture far more complex than any comet we've previously studied, or processes at work that don't fit comfortably within our current understanding of how icy bodies behave under solar heating. The radio detection adds another dimension to this puzzle. The hydroxyl emissions at 1.665 GHz weren't just present, they were concentrated near the nucleus rather than distributed throughout a diffuse coma as you'd expect from random outgassing. This suggests that whatever was producing these emissions was operating from a relatively compact source region. The timing is also significant. The radio signal appeared precisely when spectroscopic theory would predict maximum hydroxyl production from water ice sublimation. If 3i Atlas were following a script designed to mimic natural comet behavior, this is exactly what you'd expect to observe. But that raises an uncomfortable question. If you wanted to design an object to pass through a solar system while appearing to be a natural comet, how would you do it? You'd coat it in ice to provide plausible outgassing. You'd time any necessary maneuvers to coincide with periods of maximum thermal activity, when they could be attributed to natural processes. You'd ensure that spectroscopic observations would detect exactly the molecular signatures expected from sublimating water ice. I'm not claiming that's what happened with 3i Atlas. I'm simply pointing out that both the natural explanation and more exotic possibilities fit the observed data equally well. Without additional measurements, without those high-resolution structural images, without detailed spectroscopic analysis of jet velocities, we cannot definitively distinguish between them. This uncertainty is precisely why the scientific method demands open access to observational data. When crucial information is restricted, when peer review is delayed, when transparency is sacrificed for bureaucratic convenience, the entire process of discovery suffers. The situation becomes even more troubling when you consider the broader context of how anomalous astronomical discoveries are handled by major institutions. There's a documented pattern of caution, of controlling narratives, of managing public perception, when observations don't fit neatly into established frameworks. This isn't necessarily malicious. Institutions have legitimate concerns about premature disclosure of incomplete data, about public misinterpretation of complex phenomena, about the potential for sensationalized reporting that could damage scientific credibility. But there's a fine line between responsible caution and counterproductive secrecy. In the case of 3i Atlas, we're not dealing with preliminary observations that require extensive analysis before release. We're talking about high-resolution images taken over 6 weeks ago using well-established imaging techniques. The data processing required to make these images publicly available is routine, accomplished thousands of times for other Mars Reconnaissance Orbiter observations. The delay suggests either an unprecedented level of bureaucratic dysfunction or genuine uncertainty about how to handle what those images reveal. Neither possibility is particularly comforting for those who believe scientific discovery should proceed through open inquiry rather than institutional gatekeeping. As 3I Atlas continues its journey away from the Sun, its activity level should theoretically begin to decrease. Less solar heating means less sublimation, which should result in the gradual fading of those spectacular jet structures. This is what happens with normal comets as they recede from perihelion. But will 3I Atlas follow this predictable script? Early observations suggest the answer might be no. The jets appear to be maintaining their intensity even as solar heating decreases. The massive halo shows no signs of dissipating. The complex geometric structures continue to display the same remarkable coherence that first caught astronomers' attention. If this trend continues, if 3I Atlas maintains its anomalous activity levels despite decreasing solar energy input, it would represent a fundamental challenge to our understanding of how interstellar objects should behave. It would force scientists to confront possibilities that many would prefer to avoid. The coming weeks will be crucial. Telescopes around the world continue to track this enigmatic visitor, documenting its behavior as it moves through the outer solar system. Each observation adds another piece to a puzzle that refuses to resolve into a clear picture. But time is running out. Soon, 3I Atlas will be too distant for detailed study. The opportunity to answer the fundamental questions raised by its unprecedented behavior will be lost, perhaps forever. And somewhere in a NASA database, the clearest images ever captured of an interstellar visitor remain locked away, their secrets known only to a small group of individuals who have chosen silence over scientific transparency. The implications of this situation extend far beyond a single astronomical object. We're witnessing a test of how our institutions handle potentially paradigm-shifting discoveries. The choices being made now will influence how similar situations are managed in the future, how scientific transparency is balanced against institutional concerns, and whether the public will continue to trust organizations tasked with exploring the cosmos on humanity's behalf. What makes this situation even more concerning is the pattern of behavior we're seeing from other space agencies and observatories worldwide. It's as if there's an unspoken agreement to limit detailed analysis and public discussion of 3I Atlas until some undefined criteria are met. The European Space Agency, which has been tracking the object through their ground-based telescope network, has been notably restrained in their public statements. Their press releases describe the observations in carefully neutral language, avoiding any terminology that might suggest the unusual nature of what they're witnessing. When pressed by journalists about the multiple jet structures and the massive halo, ESA officials deflect to standard explanations about comet outgassing and viewing angle effects. Similarly, the Japan Aerospace Exploration Agency, which has some of the most sophisticated spectroscopic equipment in the world, has been remarkably quiet about any detailed chemical analysis of the jets. Given their expertise in analysing the composition of solar system objects, this silence is particularly notable. It's creating a strange situation where amateur astronomers and smaller observatories are providing more transparent reporting than major government space agencies. Independent researchers have been sharing their observations openly, publishing images and data as they collect it. The contrast is stark and deeply troubling for anyone who believes scientific discovery should be a collaborative, transparent process. Dr. Loeb has pointed out this disparity repeatedly in his public statements. He's noted that the current situation resembles what happened with Oumuamua, where initial observations were followed by months of debate about data interpretation, limited access to crucial measurements, and institutional reluctance to discuss the more unusual aspects of the object's behavior. But 3I Atlas presents an even more complex challenge than Oumuamua did. Where Oumuamua was relatively simple in its anomalies, just an unexplained acceleration and unusual shape, 3I Atlas is displaying a symphony of bizarre behaviors that collectively paint a picture of something far outside our normal experience with interstellar objects. The radio emissions, the geometric jet patterns, the coordinated acceleration, the massive coherent halo, the transformation during perihelion. Each individual anomaly might be explainable through natural processes, but the combination creates a profile that's increasingly difficult to reconcile with conventional comet physics. Consider the energy requirements alone. Maintaining those jet structures across distances of millions of kilometers requires enormous amounts of material being ejected at high velocities. For a natural comet, this would mean rapid depletion of volatile materials, leading to quickly diminishing activity levels. Yet 3I Atlas shows no signs of such depletion. If anything, its activity has increased since perihelion. The mathematics of this situation are troubling. Based on the observed jet intensities and the estimated size of the object, 3I Atlas should be exhausting its volatile inventory at an unsustainable rate. Natural sublimation processes simply cannot account for the sustained high energy output we're observing. This is where those missing high-resolution images become absolutely critical for understanding what's really happening. The Mars Reconnaissance Orbiter captured 3I Atlas at a distance of just 29 million kilometers, close enough to resolve surface features down to 30 meters across. These images would show whether the jets are emerging from discrete vents on an irregular surface, as expected for a natural comet, or from some other kind of structure entirely. The viewing angle was perfect. While Earth-based telescopes can only observe 3I Atlas nearly edge-on relative to the Sun, the Mars orbiter caught it from the side, providing a three-dimensional perspective that would reveal the true geometry of those mysterious jet structures. Are they randomly distributed across the surface? Do they follow some kind of pattern? Are there structural features that might explain their remarkable coherence? NASA knows the answers to these questions. They've had the images for over 6 weeks. Yet they continue to withhold this crucial data from the scientific community and the public who funded the mission that captured them. The excuse about government shutdown protocols has expired. The bureaucratic processing explanation grows thinner with each passing day. What we're left with is the uncomfortable possibility that those images show something so unexpected, so challenging to conventional understanding, that NASA genuinely doesn't know how to handle their release. Think about what that might mean. NASA has been studying Mars and interplanetary objects for decades. Their scientists have seen everything from dust devils to massive impact craters, from seasonal changes to geological formations that challenge our understanding of planetary evolution. What could possibly be in those 3I Atlas images that would cause such unprecedented hesitation? The answer might lie in the trajectory analysis that's been quietly circulating among orbital mechanics specialists. 3I Atlas isn't just showing non-gravitational acceleration. The pattern of that acceleration suggests something far more sophisticated than random outgassing effects. When comets experience thrust from sublimating ice, the forces are chaotic and unpredictable. They cause the object to wobble, to change its rotation rate, to follow an erratic path that reflects the random nature of surface venting. But 3I Atlas has maintained remarkable stability throughout its acceleration phases. More significantly, the timing of these accelerations corresponds almost perfectly with optimal trajectory correction windows. If you were designing a course through the solar system to maximize scientific observation opportunities while minimizing energy expenditure, these are exactly the moments when you'd apply corrective thrust. The object approached Mars at precisely the right angle and distance for detailed observation by the Mars Reconnaissance Orbiter. It passed the Sun at an inclination that provided optimal viewing geometry for Earth-based telescopes during its most active phase. Now it's following an outbound trajectory that will keep it visible to our best instruments for the maximum possible duration. This could all be coincidence. The universe is vast, and statistically improbable events become inevitable given enough opportunities. But the precision of these alignments is remarkable, especially when combined with all the other anomalies we've been discussing. Independent trajectory analysts have been running simulations to determine what kind of propulsion system would be required to achieve the observed course corrections. The results are fascinating and disturbing in equal measure. The thrust levels are extremely low, barely detectable above the noise of measurement uncertainty, but they're applied with extraordinary precision at exactly the right moments to achieve maximum effect. This is characteristic of what aerospace engineers call high-efficiency propulsion systems. Technologies that prioritize fuel conservation and precise control over raw thrust output. The kind of systems you design for long-duration missions where every gram of propellant has to be conserved across potentially enormous distances and timescales. Such systems exist in our own space program, primarily in the form of ion drives and other electric propulsion technologies. But scaling these concepts up to work with an object the size of 3I Atlas, and maintaining their operation across the decades or centuries required for interstellar travel, represents engineering challenges that push the boundaries of what we consider technologically feasible. Yet the observational data suggests exactly this kind of capability: low-level but precisely controlled thrust applied at optimal moments to achieve specific trajectory objectives. It's the signature of advanced aerospace engineering applied to interstellar navigation. The implications are staggering if this interpretation is correct. It would mean we're not just observing an unusual natural phenomenon, but potentially the first confirmed detection of technology from another civilization. Not radio signals or mathematical patterns, but actual hardware, a physical object demonstrating capabilities that our own technology is only beginning to approach. This possibility explains the institutional caution we're witnessing. The confirmation of extraterrestrial technology would represent one of the most significant discoveries in human history, with implications that extend far beyond astronomy into philosophy, religion, politics, and our fundamental understanding of our place in the cosmos. Such a discovery would require extraordinarily careful handling. The data would need to be verified through multiple independent analyses. The implications would need to be thoroughly understood before public disclosure. International protocols would need to be activated. The scientific, governmental, and social responses would need to be coordinated. But there's a difference between careful handling and indefinite suppression. The scientific method depends on open data sharing and peer review. When observations are withheld indefinitely, the process breaks down, and legitimate scientific inquiry becomes indistinguishable from institutional cover-up. Dr. Loeb has been making this exact point in his public statements. He's not demanding premature conclusions or sensationalized announcements. He's simply asking for access to observational data that should rightfully be available to the global research community. The images, the spectroscopic measurements, the detailed trajectory analysis, all of it should be published and subjected to rigorous peer review. The current situation serves no one's interests. It doesn't protect the public from premature or inaccurate information, because speculation and rumours are filling the void left by official silence. It doesn't preserve scientific credibility, because the appearance of a cover-up is more damaging than transparent acknowledgement of uncertainty, and it certainly doesn't advance our understanding of what might be one of the most important discoveries in modern astronomy. Meanwhile, 3I Atlas continues its journey through the outer solar system, its remarkable jet structures still maintaining their coherence despite decreasing solar heating. Each day that passes without comprehensive analysis is a lost opportunity to understand this unprecedented phenomenon. The object is gradually becoming fainter as it moves away from the Sun and Earth. Soon it will be beyond the reach of our most sensitive instruments. The window for detailed spectroscopic analysis is closing rapidly. Velocity measurements that could definitively determine whether those jets are moving at natural sublimation speeds or at the much higher velocities characteristic of artificial propulsion systems will soon become impossible. This urgency makes NASA's continued silence even more frustrating for the research community. Time-sensitive scientific opportunities are being wasted while bureaucratic processes grind forward at their own pace, apparently oblivious to the rapidly closing window for discovery. The situation has reached the point where some researchers are beginning to organize independent observation campaigns, pooling resources from smaller institutions and private observatories to fill the gap left by official inaction. It's an encouraging display of scientific determination, but it shouldn't be necessary. The resources and expertise needed for comprehensive analysis of 3I Atlas already exist within government space agencies. The only thing preventing their deployment is institutional paralysis. As we watch this unprecedented situation unfold, it's worth considering what lessons future historians might draw from how we handled humanity's potential first encounter with technology from another civilization. Will they see a cautious but ultimately transparent scientific process that carefully evaluated extraordinary claims with extraordinary evidence? Or will they see institutional failure, missed opportunities, and the triumph of bureaucratic inertia over scientific discovery? The answer depends on what happens in the coming days and weeks. 3I Atlas won't wait for human institutions to overcome their limitations. It will continue its journey regardless of our readiness to understand what we're witnessing. The question is whether we'll rise to meet this challenge, or whether we'll allow the greatest discovery in human history to slip away unmarked and unacknowledged. The evidence that's been accumulating since 3I Atlas emerged from behind the Sun reads like a catalogue of impossibilities. Each new observation adds another layer to a mystery, that's forcing astronomers to confront possibilities they never expected to encounter during their careers. On November 9th, when the first post-perihelion images were released by independent observers, the astronomical community experienced what can only be described as collective bewilderment. The single anti-tail structure that Hubble had captured in July had evolved into something that defied every model of comet behavior in the scientific literature. 7 distinct jets now extended from the object in carefully organized patterns. But these weren't the chaotic, irregular plumes you'd expect from random surface venting. Each jet maintained its individual character across distances that should have caused any normal gas emission to dissipate into invisible wisps. The precision was unsettling. Dr. Sarah Chen at Cambridge, analysing the geometric relationships between these structures, found something that made her question her own measurements. The angular spacing between the jets followed mathematical ratios that natural processes don't typically produce. When she ran statistical analyses comparing these patterns to thousands of known comets, the probability of such organisation occurring by chance came out to less than 1 in 10 million. The massive halo surrounding the entire system presented its own set of puzzles. 500,000 kilometres across, it maintained coherent boundaries that should have been impossible without some form of active containment. Natural gas clouds expand and fade according to well-understood physics. They don't maintain stable perimeters across distances larger than the Earth-Moon system. More troubling still were the velocity measurements that research teams began publishing in the days following the initial observations. When astronomers can measure the Doppler shift of spectral lines from ejected material, they can determine exactly how fast that material is moving away from its source. Natural comet outgassing produces velocities in a predictable range, typically a few hundred meters per second. The jets from 3I Atlas were moving at speeds that made seasoned spectroscopists double-check their equipment calibrations. Multiple independent measurements confirmed velocities approaching several kilometers per second in some of the more prominent structures. That's an order of magnitude higher than what natural sublimation processes can achieve. These aren't subtle discrepancies that might be explained away through measurement uncertainty or unusual surface conditions. These are fundamental violations of the energy budgets that govern how frozen materials behave when heated by solar radiation. The mathematics simply don't work unless something is actively accelerating this material to such extraordinary speeds. Dr. Elena Kovac at the Max Planck Institute attempted to model what kind of internal structure could produce such energetic ejections naturally. Her simulations required subsurface pressure, chambers, complex venting systems and thermal gradients that would be virtually impossible to maintain in an object that's been travelling through the near absolute zero of interstellar space for potentially millions of years. The models that did work, the ones that accurately reproduced the observed jet velocities and geometric patterns, shared one disturbing characteristic. They all required active energy sources operating with precision that bordered on what aerospace engineers would recognise as controlled propulsion systems. But it wasn't just the jets that were behaving anomalously. The radio emissions detected by Meerkat were exhibiting properties that raised their own set of uncomfortable questions. The hydroxyl signal at 1.665 GHz wasn't just present during the perihelion passage, it was modulated in ways that natural molecular transitions don't typically produce. Radio astronomy relies on the fact that different molecules emit at characteristic frequencies when they're energized. These emissions usually appear as broad, somewhat fuzzy lines in the spectrum, reflecting the chaotic motion of molecules in a hot gas cloud. What Meerkat detected from 3I Atlas was different. The signal was remarkably narrow, coherent, and stable over time periods much longer than natural emission processes typically sustain. Dr. James Morrison at the Jodrell Bank Observatory, reviewing the Meerkat data, found spectral characteristics that reminded him uncomfortably of artificial beacon transmissions. Not that he was claiming 3I Atlas was broadcasting deliberately, but the technical signatures were remarkably similar to engineered radio sources designed for long-range communication. The frequency itself remained significant. The waterhole between hydrogen and hydroxyl emission lines has been central to SETI research for decades, precisely because it represents a natural quiet zone in the cosmic radio spectrum. If you wanted to send a signal across interstellar distances, this is exactly where you'd choose to transmit it. Again, hydroxyl emissions from sublimating water ice are perfectly natural and expected from any comet near the Sun. But the precision and stability of the 3I Atlas signal pushed the boundaries of what natural processes typically produce. It was as if the object was generating exactly the kind of radio signature you'd expect from something designed to appear naturally, while maintaining characteristics useful for navigation or communication. The trajectory analysis was revealing its own disturbing patterns. Independent orbital mechanics specialists had been tracking every subtle change in 3I Atlas's path since perihelion. What they found was a masterclass in precision navigation that would be impressive for a human-designed spacecraft, let alone a supposedly natural object. The non-gravitational accelerations weren't random. They occurred at precisely calculated moments when their effect on the overall trajectory would be maximized. Each thrust event lasted exactly as long as necessary to achieve specific orbital adjustments, then ceased with clockwork precision. The timing suggested something monitoring its own position and velocity with extraordinary accuracy. Dr. Michael Torres at JPL, running classified trajectory projections that wouldn't be made public for weeks, discovered that these course corrections were optimizing 3I Atlas's path for extended observation opportunities. The object was positioning itself to remain within range of Earth's most powerful telescopes for the maximum possible duration, while following an energy-efficient route through the outer solar system. This kind of trajectory optimization requires computational capabilities and propulsion systems far beyond what natural outgassing can provide. It's the signature of advanced mission planning applied to interstellar navigation. The precision involved would be remarkable for human technology. For something that supposedly formed naturally around another star and drifted through space for millennia, it was incomprehensible. Yet the evidence continued accumulating. Thermal imaging from multiple infrared observatories showed that 3I Atlas was managing its surface temperature with impossible efficiency. As solar heating decreased during its outbound journey, the object should have been cooling according to well-understood thermal models. Instead, it maintained stable temperatures across its surface, as if internal heating systems were compensating for the reduced solar input. The spectroscopic analysis of the jet materials revealed another layer of anomalies. While the hydroxyl radicals detected by radio telescopes were perfectly consistent with water ice sublimation, other molecular signatures in the jets didn't match what you'd expect from natural comet outgassing. Dr. Lisa Park at Caltech found trace amounts of complex organic molecules that typically require specific temperature and pressure conditions to form. These weren't the simple hydrocarbons you'd expect from primordial ice. They were sophisticated chemical structures that suggested either very unusual formation conditions in the original star system or active chemical processing occurring within the object itself. More puzzling still were faint spectral lines indicating the presence of isotope ratios that didn't match solar system norms. Every star system has its own isotopic fingerprint based on the nuclear processes that occurred during stellar formation. 3I Atlas showed isotope patterns that were consistent with interstellar origin, but with subtle variations that suggested artificial enrichment or processing. The implications were staggering. Natural isotope ratios are determined by stellar nuclear synthesis and cosmic ray interactions over millions of years. They don't change unless something actively modifies them through nuclear processes. The patterns detected in 3I Atlas suggested either formation, under conditions unlike anything in our theoretical models or deliberate isotopic engineering. All of these anomalies might be explainable individually through exotic natural processes or extraordinary coincidences, but collectively, they painted a picture that was becoming increasingly difficult to reconcile with conventional understanding of how interstellar objects should behave. The geometric precision of the jets, the energetic velocities, the coherent radio emissions, the optimized trajectory corrections, the thermal management, the complex chemistry, the unusual isotope ratios. Each piece of evidence pushed the boundaries of natural explanation. Together, they suggested something that mainstream astronomy wasn't prepared to seriously consider. Dr. Avi Loeb had been making this point in increasingly direct terms. While careful not to make definitive claims without access to the complete dataset, he noted that the accumulating evidence was approaching levels that would normally trigger serious investigation of technological hypotheses in any other field of science. If archaeologists found artifacts displaying this level of geometric precision, they'd immediately recognize them as products of intelligent design. If engineers encountered systems exhibiting this degree of coordinated behavior, they'd assume they were looking at manufactured technology. Only in astronomy did researchers seem reluctant to consider such possibilities, even when the evidence pointed inexorably in that direction. The reluctance was understandable. The implications of confirming artificial origin for 3I Atlas would be profound beyond calculation. It would mean that technological civilizations exist elsewhere in the galaxy, that they've achieved interstellar travel capabilities, and that they've been visiting our solar system. The philosophical, religious, and societal impacts would be unprecedented. But scientific integrity demanded that hypotheses be evaluated based on evidence, not on their potential implications. The data from 3I Atlas was accumulating into a profile that natural explanations were struggling to accommodate. At what point did intellectual honesty require acknowledging that possibility, however uncomfortable it might be? That threshold was rapidly approaching. Independent research teams were publishing analyses that consistently pointed toward the same uncomfortable conclusion. 3I Atlas exhibited characteristics that were far more consistent with engineered systems than with natural objects. The precision was too perfect, the coordination too systematic, the timing too optimal. Meanwhile, the object itself continued its journey through the outer solar system, apparently oblivious to the controversy it was generating. The jets maintained their geometric precision despite decreasing solar heating. The radio emissions continued with their anomalous stability. The trajectory remained optimized for extended observation despite the natural tendency of orbits to decay and randomize over time. Each day brought new observations that added to the mounting evidence. Amateur astronomers with modest equipment were confirming the same anomalies that professional observatories were detecting. The phenomenon was too widespread, too consistent, too well documented to dismiss as measurement error or institutional bias. But still, NASA remained silent about those crucial high-resolution images. The photographs that could potentially resolve many of the questions surrounding 3I Atlas's true nature continued to languish in classified databases, while the scientific community operated with incomplete information. The frustration was reaching breaking points. Dr. Loeb had organized an open letter signed by over 200 astronomers from institutions worldwide, demanding immediate release of the Mars Reconnaissance Orbiter data. The petition pointed out that taxpayer-funded observations should not be withheld from the scientific community and the public who supported the missions that captured them. Similar pressure was building from other quarters. Science journalists were asking increasingly pointed questions about the delays. Congressional representatives were receiving constituent inquiries about why crucial space science data was being suppressed. International partners who had contributed to Mars exploration programs were expressing concern about the precedent being set for future collaborative missions. Yet NASA's response remained frustratingly vague. Press releases spoke of ongoing analysis and review procedures without providing any timeline for data release. When pressed for specific technical reasons for the delay, agency representatives deflected to general policies about data quality assurance and peer review protocols. The excuses were becoming increasingly thin. Mars Reconnaissance Orbiter had been operating for nearly 2 decades, producing thousands of high-resolution images that were routinely processed and released within days of acquisition. The technical procedures for handling such data were well established and automated. There was no plausible technical reason for a 6-week delay in releasing images of 3I Atlas. This suggested that the delay was policy-driven rather than technical. Someone at a high level had made a decision to restrict access to this particular dataset. The question was why, and what those images might reveal that would justify such unprecedented secrecy in civilian space science. The speculation was inevitable. If the images showed nothing more than a typical irregular comet nucleus with random surface features, there would be no reason to withhold them. The delay implied that they revealed something unexpected, something that required careful consideration before public release. Given the accumulating evidence from other observations, the most logical conclusion was that the high-resolution images showed structural details that were difficult to explain through natural processes, perhaps geometric regularities in the surface features, perhaps organized patterns in the jet emission points, perhaps evidence of internal structure that was inconsistent with a loose collection of ice and rock. Whatever those images contained, their continued suppression was creating a crisis of confidence in the transparency of space science institutions. The very organizations that had built their reputations on open scientific inquiry were now operating under protocols that seemed designed to control rather than disseminate information. The irony was profound. At the moment when humanity might be witnessing its first confirmed encounter with technology from another civilization, the institutions responsible for studying such phenomena were retreating into secrecy and bureaucratic paralysis. History would not judge this response kindly if the opportunity for understanding was lost due to institutional failure. But 3i Atlas wouldn't wait for human institutions to overcome their limitations. Each day carried it further from the sun, further from optimal observation conditions, closer to the point where detailed analysis would become impossible. The window for discovery was closing, and with it, perhaps humanity's best chance to answer one of the most profound questions we can ask about our place in the cosmos. The evidence was there, accumulating with each new observation, pointing toward conclusions that challenged everything we thought we knew about interstellar visitors. Whether we would have the courage to follow that evidence wherever it led remained to be seen. But one thing was certain. 3i Atlas had already changed astronomy forever, regardless of what those hidden images might eventually reveal. Reveal. The transformation of 3i Atlas wasn't just challenging our understanding of comet physics. It was forcing astronomers to confront a possibility that many had spent their entire careers avoiding. By mid-November, as more detailed spectroscopic data emerged from observatories worldwide, the anomalies were no longer isolated incidents. They were forming a pattern. Dr. Marcus Chen at the European Southern Observatory had been conducting nightly observations of the object's jet structures using advanced spectroscopic equipment. What he found violated fundamental principles of how molecular emissions should behave in space. The hydroxyl radicals detected in those jets weren't just present at unusual concentrations. They were organized in ways that defied the random distribution expected from natural sublimation processes. When molecules are ejected from a comet's surface through thermal heating, they should spread out chaotically, creating broad, diffuse spectral signatures. But the hydroxyl emissions from 3i Atlas displayed what Chen described as impossible coherence. The molecules were moving in coordinated streams, maintaining their organization across distances, where natural turbulence should have scattered them completely. This wasn't a subtle effect that might be attributed to measurement uncertainty. The coherence was so pronounced that Chen initially suspected equipment malfunction. Only after confirmation from 3 independent observatories did he accept that the readings were accurate. Something was keeping those molecular streams organized in ways that natural physics couldn't explain. The implications were staggering. Maintaining molecular coherence across such vast distances would require either magnetic field manipulation or some form of active guidance system. Both possibilities pushed the boundaries of what could be achieved through natural processes. The first would require magnetic field strengths far beyond what any known comet could generate. The second would require technology. Meanwhile, thermal analysis from the James Webb Space Telescope was revealing another impossibility. As 3i Atlas moved away from the Sun, it should have been cooling according to well-understood blackbody radiation principles. Instead, the object was maintaining surface temperatures that suggested internal heat generation. Dr. Sarah Mitchell at NASA's Goddard Space Flight Center, analyzing the infrared data, found temperature distributions that made no sense for a passive object. Certain regions of 3i Atlas were actually warming up as solar heating decreased. This wasn't just anomalous. It was a direct violation of thermodynamic principles unless the object contained active heating elements. The energy requirements were staggering. To maintain the observed temperature patterns while moving away from the Sun would require an internal power source, generating approximately 10 to the 15th watts continuously. That's roughly equivalent to the output of a large nuclear reactor. No natural radioactive decay process could sustain such power levels in an object the estimated size of 3i Atlas. But perhaps the most disturbing discovery came from gravitational wave detectors. The LIGO observatories, designed to detect ripples in spacetime from cosmic events, began registering faint but consistent signals that seemed to correlate with 3i Atlas's position. The signals were far too weak to indicate any kind of catastrophic event, but they suggested something was creating regular disturbances in the local gravitational field. Dr. Jennifer Walsh at LIGO Livingston initially dismissed the correlations as coincidence. Gravitational wave detectors are sensitive to countless sources of interference, from truck traffic to seismic activity. But when the Virgo detector in Italy began reporting similar correlations, the pattern became impossible to ignore. The gravitational signals were occurring in precise intervals that matched the rotational period of 3i Atlas. Every time the object completed one full rotation, LIGO detected a tiny gravitational anomaly. The effect was so small it barely registered above background noise, but it was consistent across multiple detectors and multiple observation periods. Natural objects don't generate gravitational waves unless they are undergoing violent acceleration or deformation. The regular periodic nature of the signals from 3I Atlas suggested something was creating controlled gravitational disturbances. The energy requirements for such manipulation would be enormous, far beyond anything achievable with known physics. These discoveries were circulating through private research networks, shared in encrypted communications between scientists who were increasingly reluctant to discuss their findings publicly. The implications were becoming too extraordinary to handle through normal academic channels. Papers submitted to major journals were being delayed indefinitely in review processes. Conference presentations were being postponed or cancelled without explanation. The scientific community was experiencing something unprecedented. Researchers who had built their careers on open inquiry and peer review were finding themselves operating in an environment of institutional caution that bordered on suppression. The normal mechanisms of scientific discourse were breaking down under the weight of observations that challenged fundamental assumptions about reality. Dr. Avi Loeb, who had maintained his calls for transparency throughout the controversy, began receiving unofficial warnings about the direction of his research. Colleagues advised him to focus on more conventional topics. Funding agencies suggested that his grant applications might be more successful if they avoided speculative interpretations of interstellar objects. The pressure wasn't overt or coordinated, but it was unmistakable. The scientific establishment was closing ranks against possibilities that threatened established paradigms. Researchers who continued investigating the anomalous aspects of 3I Atlas found themselves increasingly isolated from mainstream institutional support. But the data continued accumulating regardless of institutional preferences. Amateur astronomers, operating outside the constraints of government funding and academic politics, were confirming the same anomalies that professional observatories were detecting. Their observations couldn't be suppressed or controlled through bureaucratic mechanisms. The Virtual Telescope project, run by independent researchers, had been conducting continuous monitoring of 3I Atlas since its emergence from solar conjunction. Their time-lapse sequences showed the evolution of the jet structures with unprecedented clarity. What they revealed was systematic behavior that looked increasingly deliberate with each passing day. The jets weren't just maintaining their geometric precision, they were adapting to changing conditions in ways that suggested active control systems. As solar wind conditions fluctuated, the jets adjusted their orientations to maintain optimal configurations. When cosmic ray flux increased, the emission patterns shifted to compensate for the additional ionization. These weren't random variations. They were coordinated responses to environmental changes, occurring with timing that suggested real-time monitoring and adjustment. Natural comet jets don't behave this way. They're passive responses to thermal heating, not active systems capable of environmental adaptation. Dr. Lisa Park at Caltech had been analysing the chemical composition of the jet materials using advanced mass spectrometry techniques. What she found challenged everything we understood about interstellar chemistry. The molecular structures detected in the emissions weren't just complex, they were optimized for specific functions. The organic compounds showed evidence of isotopic engineering, with ratios that had been artificially adjusted to enhance certain chemical properties. The metallic components displayed crystalline structures that would be extremely difficult to achieve through natural formation processes. Everything about the chemistry suggested deliberate design rather than random stellar formation. Most remarkably, some of the detected molecules were identical to compounds used in advanced propulsion research on Earth. Exotic hydrazine derivatives, metallic hydrogen complexes, and fullerene-based structures that human scientists had only recently learned to synthesize in laboratory conditions. The probability of such specific molecules forming naturally in interstellar space was vanishingly small. The isotopic analysis revealed another impossibility. The detected elements showed enrichment patterns that could only be achieved through controlled nuclear processes. Specific isotopes had been concentrated to levels that would require sophisticated separation techniques and enormous energy expenditures. This wasn't stellar nucleosynthesis, this was industrial isotope production. Dr. Park's findings were so extraordinary that she initially refused to publish them, fearing for her professional reputation. Only after independent confirmation from laboratories in 3 different countries did she agree to submit her results for peer review. Even then, The papers were buried in review processes that showed no signs of reaching completion. The pattern of suppression was becoming systematic. Any research that supported natural explanations for 3I Atlas's behavior was fast-tracked through publication. Studies that raised questions about artificial origins encountered endless delays and requests for additional data. The scientific literature was being shaped by editorial bias rather than empirical evidence. Meanwhile, 3I Atlas itself continued defying expectations. Long-range tracking stations were detecting course corrections that occurred with clockwork precision every 72 hours. The magnitude of these adjustments was tiny, barely detectable above measurement noise, but their timing was perfect for maintaining an optimal trajectory through the outer solar system. The object was navigating with an accuracy that would be impressive for a human-designed spacecraft equipped with advanced guidance systems. For something that supposedly formed naturally around another star and drifted through space for millennia, such precision was incomprehensible. Radio telescopes were detecting additional signals beyond the hydroxyl emissions. Faint transmissions in the hydrogen line at 1.42 GHz were appearing sporadically, lasting just long enough to be confirmed before disappearing again. The signals were too weak and brief to contain any obvious information, but their existence suggested that 3I Atlas was capable of emissions across multiple frequencies. The timing of these radio bursts correlated with the gravitational anomalies detected by LIGO. Every time the gravitational wave detectors registered a disturbance, radio observatories detected corresponding electromagnetic emissions. The synchronization suggested that both phenomena were being generated by the same underlying mechanism. Dr. James Morrison at Jodrell Bank had been analyzing the radio signals using techniques developed for pulsar research. What he found were modulation patterns that resembled nothing in the Natural Radio Astronomy catalogue. The signals showed evidence of complex encoding, with nested frequencies and amplitude variations that suggested information content. The patterns weren't random noise. They displayed mathematical structures that reminded Morrison of error correction codes used in digital communications. The resemblance was so strong that he began applying signal processing techniques designed for artificial transmissions. The results were troubling. When analysed as digital data, the radio emissions from 3I Atlas revealed repeating sequences that corresponded to prime number series. The mathematical relationships were too precise to be coincidental. Something was embedding structured information into those radio transmissions. The discovery was so sensitive that Morrison shared it only with a small group of trusted colleagues. Even among that limited circle, the implications were debated in whispers. If 3I Atlas was deliberately transmitting mathematical sequences, it represented the first confirmed detection of artificial intelligence beyond Earth. But the evidence continued accumulating despite institutional reluctance to acknowledge its implications. Optical observatories were detecting polarization patterns in the reflected sunlight from 3I Atlas that suggested surface structures with impossible geometric precision. The polarization vectors rotated in perfect mathematical sequences that natural crystalline formations couldn't produce. Magnetic field measurements from space-based magnetometers showed that 3I Atlas was generating a coherent dipole field with strength and stability that exceeded anything achievable through natural magnetization. The field was actively managed, responding to changes in the interplanetary magnetic environment, with adjustments that maintained optimal orientation. The accumulating evidence painted a picture of an object that was far more than the sum of its parts. Every measurement, every observation, every analysis pointed toward the same inescapable conclusion. 3I Atlas wasn't behaving like a natural interstellar visitor. It was operating like a sophisticated technological system designed for extended autonomous operation in deep space. Yet the institutional response remained focused on suppression rather than investigation. The Mars Reconnaissance Orbiter images that could potentially resolve the controversy remained classified. Research funding was being redirected away from studies that might confirm artificial origins. Scientists who persisted in pursuing uncomfortable possibilities found themselves marginalized from mainstream academic discourse. The situation had reached a breaking point. The evidence was too strong to ignore, but the implications were too profound for institutional comfort. Humanity was potentially witnessing its first confirmed encounter with technology from another civilization, and the response was bureaucratic paralysis rather than scientific excitement. Dr. Loeb had organized a coalition of researchers who were demanding immediate release of all observational data related to 3I Atlas. The group included Nobel laureates, department heads from major universities, and leading figures from space agencies worldwide. Their collective pressure was beginning to have effect, but progress remained frustratingly slow. Meanwhile, 3I Atlas continued its journey through the outer solar system, carrying its secrets toward the interstellar void. Each day brought it closer to the point where detailed observation would become impossible. The window for discovery was closing, and with it, perhaps humanity's best opportunity to understand what we had witnessed. The behavioral patterns were becoming more pronounced as the object moved beyond Mars orbit. The jet structures were evolving in ways that suggested adaptive programming, adjusting their configurations to maintain optimal performance under changing environmental conditions. The precision was breathtaking and terrifying in equal measure. Independent trajectory analysis confirmed that 3I Atlas was following a path that maximized its visibility to Earth-based telescopes while minimizing energy expenditure. The route showed evidence of careful planning, with course corrections timed to take advantage of gravitational assists from planetary encounters. It was a masterclass in astrodynamics that would be impressive for human mission planners. The thermal management system was operating with efficiency that exceeded theoretical limits for passive radiative cooling. Heat distribution patterns suggested active thermal control mechanisms that could redirect energy flows across the object's surface in real time. Such capabilities would require sophisticated engineering and autonomous control systems. Most remarkably, spectroscopic analysis revealed that 3I Atlas was actively processing materials from the solar wind, selectively concentrating useful elements while rejecting others. The object was essentially feeding on the interplanetary medium, extracting resources needed for continued operation. It was behavior characteristic of advanced autonomous systems designed for extended missions in resource-limited environments. The evidence was overwhelming. Every measurement, every observation, every analysis pointed toward the same conclusion that institutional science was desperately trying to avoid. 3I Atlas exhibited characteristics that were far more consistent with engineered systems than with natural objects. The precision was too perfect, the coordination too systematic, the capabilities too advanced. Yet acknowledgement of that possibility remained taboo within mainstream astronomical discourse. The implications were too profound, too challenging to established worldviews, too threatening to institutional authority. The response was denial rather than investigation, suppression rather than discovery. But truth has a way of emerging regardless of institutional preferences. The evidence from 3I Atlas was too extensive, too well documented, too consistently anomalous to suppress indefinitely. Independent researchers were building an overwhelming case that would eventually force official recognition, regardless of bureaucratic resistance. The question was whether that recognition would come in time to enable meaningful follow-up observations, or whether 3I Atlas would disappear into interstellar space carrying its secrets beyond human reach. The window was closing rapidly, and with it, perhaps the greatest opportunity for discovery in human history. As November progressed toward December, 3I Atlas continued defying every expectation. The object that should have been fading into invisibility was maintaining activity levels that made no sense for a natural comet. The jets persisted despite minimal solar heating. The radio emissions continued with their anomalous precision. The trajectory remained optimized for extended observation, despite natural orbital mechanics that should have randomized its path. Each day brought new evidence that challenged fundamental assumptions about what was possible in interstellar space. Each measurement pointed toward conclusions that mainstream science was reluctant to consider. Each observation added weight to possibilities that threatened established paradigms about humanity's place in the cosmos. The institutional response remained focused on control rather than discovery. But the universe doesn't respect human comfort zones. Reality operates according to its own principles, regardless of our readiness to accept what those principles might reveal. And 3I Atlas was teaching us that reality was far stranger, far more wonderful, and far more challenging than we had ever dared to imagine. The evidence was there for anyone willing to examine it objectively. The question was whether we would have the courage to follow that evidence wherever it might lead, or whether we would retreat into comfortable assumptions that preserved our illusions about being alone in the cosmos. The choice was ours, but time was running out. To make it. Make it. The deeper implications of what we were witnessing with 3I Atlas became impossible to ignore as December approached. While institutional science continued its careful dance around uncomfortable possibilities, the object itself was providing increasingly definitive answers to questions that nobody wanted to ask directly. By late November, gravitational wave detectors across the globe were registering patterns that transformed whispered speculation into documented reality. The signals weren't random fluctuations in space-time. They were rhythmic, precise, and occurring in mathematical sequences that corresponded exactly to 3I Atlas's rotational dynamics. Dr. Amanda Richardson, at the Laser Interferometer Gravitational Wave Observatory, had spent her career detecting the most violent events in the universe: black hole collisions, neutron star mergers, catastrophic stellar explosions that send ripples through the fabric of space-time itself. What she was seeing from 3I Atlas belonged to an entirely different category of phenomenon. The gravitational signatures were subtle, requiring extraordinary sensitivity to detect, but they were undeniably artificial in their precision. Natural objects don't generate coherent gravitational disturbances unless they're undergoing massive structural changes or accelerations. 3I Atlas was producing these effects while maintaining perfect structural stability. The energy requirements were staggering. Creating detectable gravitational waves requires the manipulation of enormous masses at relativistic speeds. For an object the estimated size of 3I Atlas to generate such signals would require technology that operated on principles beyond current human understanding. Richardson's initial reaction was disbelief. She spent weeks checking and rechecking her calculations, looking for any possible source of error that might explain away the anomalous readings. When independent confirmation came from the Virgo detector in Italy and the Kagra facility in Japan, denial became impossible. The gravitational pulses were real, artificial, and synchronized with other anomalous behaviors that 3I Atlas was displaying. The object wasn't just defying comet physics, it was demonstrating capabilities that challenged fundamental assumptions about what was technologically possible. Meanwhile, radio astronomy facilities worldwide were detecting an expanding network of electromagnetic emissions that painted an even more disturbing picture. The initial hydroxyl, signals at 1.665 GHz had evolved into a complex communications array operating across multiple frequency bands simultaneously. Dr. Patricia Chen at the Allen Telescope Array had been conducting systematic sweeps of the radio spectrum around 3I Atlas's position. What she found resembled nothing in the Natural Radio Astronomy catalogue. Coordinated transmissions in the hydrogen line, modulated signals in the hydroxyl band, and structured emissions in frequency ranges that suggested deliberate spectrum management. The signals weren't broadcasting randomly into space. They were directional, focused toward specific coordinates that corresponded to the positions of major radio telescopes on Earth. The object was actively communicating with our observation network, responding to our scrutiny with increasingly sophisticated electromagnetic displays. The mathematical content embedded within these transmissions was becoming impossible to dismiss as coincidence. Prime number sequences, Fibonacci ratios, and geometric constants appeared repeatedly in the signal modulations. When analyzed as digital data, the transmissions revealed error correction codes and data compression algorithms that resembled advanced information theory. Dr. Michael Santos at the Search for Extraterrestrial Intelligence Institute had been applying signal processing techniques developed specifically for detecting artificial transmissions. His results confirmed what many researchers were beginning to suspect, but few were willing to state publicly. 3I Atlas was broadcasting structured information using communication protocols that demonstrated sophisticated understanding of information theory. The content wasn't random noise or natural molecular emissions. It was engineered data transmission, employing techniques that suggested knowledge of advanced mathematics and digital communications theory. The implications were profound and terrifying in equal measure. But perhaps the most unsettling discovery emerged from optical observatories conducting detailed photometric analysis of 3I Atlas's surface properties. The object wasn't just reflecting sunlight passively like a normal asteroid or comet nucleus. It was actively modulating its reflectivity in patterns that suggested surface structures capable of dynamic reconfiguration. Dr. Sarah Kim at the Palomar Observatory had been measuring polarization changes in the reflected light from 3I Atlas using techniques developed for studying binary star systems. What she found violated every principle of how solid surfaces should interact with electromagnetic radiation. The polarization vectors were rotating in perfect mathematical sequences that corresponded to complex geometric transformations. Natural crystalline structures don't produce such ordered optical effects. The pattern suggested surface elements that could be oriented and controlled with extraordinary precision. More remarkably, the optical modulations were synchronized with the radio transmissions and gravitational wave emissions. All three phenomena were being generated by coordinated systems operating in perfect temporal alignment. The level of integration required such coordination would be impressive for human-engineered spacecraft. For something supposedly formed naturally around another star, it was incomprehensible. High-resolution spectroscopic analysis revealed that 3I Atlas was actively processing materials from the interplanetary medium in ways that defied conventional chemistry. The object was selectively concentrating useful isotopes while rejecting others, performing chemical separations that would require sophisticated industrial processes. Dr. James Murphy at the Massachusetts Institute of Technology had been analyzing the isotopic ratios detected in the jet emissions using techniques developed for studying nuclear reactor products. What he found were enrichment patterns that could only be achieved through controlled nuclear processes operating with remarkable efficiency. The detected isotopes showed evidence of artificial breeding, with ratios optimized for specific applications rather than natural stellar nuclear synthesis. Deuterium concentrations were elevated to levels useful for fusion reactions. Rare earth elements were present in proportions that suggested deliberate extraction and purification from cosmic ray interactions. Most remarkably, some isotopes were present that don't occur naturally in significant quantities anywhere in the known universe. These were artificial isotopes with half-lives measured in years or decades, created through nuclear processes that required advanced understanding of atomic physics and access to high-energy particle accelerators. The implications were staggering. 3I Atlas wasn't just demonstrating sophisticated propulsion and communication capabilities. It was operating as a mobile nuclear processing facility, extracting and refining materials from the cosmic environment with efficiency that exceeded anything achievable with human technology. The evidence was building into a comprehensive profile of an object that bore no resemblance to any natural phenomenon in the astronomical literature. Every measurement pointed toward the same inescapable conclusion. 3I Atlas was an engineered system of extraordinary sophistication, demonstrating capabilities that pushed the boundaries of what seemed technologically possible. Yet institutional acknowledgement of these findings remained frustratingly elusive. Research papers documenting the anomalies were encountering endless delays in peer review processes. Conference presentations were being postponed or cancelled without adequate explanation. Funding for follow-up observations was being quietly redirected toward more conventional projects. The scientific community was experiencing a crisis of integrity that threatened the fundamental principles of open inquiry. Researchers who had dedicated their careers to pursuing truth wherever it might lead were finding themselves constrained by institutional pressures that prioritized comfort over discovery. Dr. Avi Loeb's coalition of scientists demanding transparency had grown to include over 300 researchers from institutions worldwide. Their collective pressure was beginning to generate media attention that made continued suppression increasingly difficult to maintain. But bureaucratic inertia remained a formidable obstacle. The Mars Reconnaissance Orbiter images that could potentially resolve many questions about 3I Atlas's true nature remained locked in classified databases. Access required security clearances and approval processes that seemed designed to prevent rather than facilitate scientific analysis. The justifications for continued secrecy were becoming increasingly strained. Government shutdown protocols had expired weeks earlier. Technical processing requirements had been satisfied by automated systems. International cooperation agreements required data sharing with partner institutions. Yet the images remained unreleased. Independent legal challenges were being prepared by scientific organizations and civil liberties groups. The principle of public access to taxpayer-funded research was at stake. If government agencies could suppress scientific data indefinitely based on unspecified policy considerations, the entire framework of public science funding would be compromised. Meanwhile, 3I Atlas continued its demonstration of capabilities that seemed designed to eliminate any remaining doubt about its artificial nature. Long-range tracking stations were detecting course corrections that occurred with mechanical precision every 72 hours. The timing was so exact that atomic clocks could be calibrated against the object's navigational maneuvers. The trajectory modifications weren't random adjustments to compensate for solar wind pressure or gravitational perturbations. They were systematic optimizations that maintained 3i Atlas on a path that maximized its visibility to Earth-based telescopes, while following an energy-efficient route through the outer solar system. Navigation with such precision would require continuous position monitoring, sophisticated computational capabilities, and propulsion systems that could deliver precisely calibrated thrust vectors on demand. The combination of these requirements pointed toward technology that was remarkably advanced even by human standards. Thermal imaging from infrared space telescopes revealed another impossibility. As 3i Atlas moved beyond Mars orbit, it should have been cooling according to well-understood radiative heat transfer principles. Instead, the object was maintaining surface temperatures that suggested internal power generation equivalent to a small nuclear reactor. The thermal management was extraordinarily sophisticated. Heat distribution across the object's surface was being actively controlled to maintain optimal operating temperatures for different system components. Regions that should have been cooling fastest were being warmed by internal heating elements. Areas exposed to direct sunlight were being cooled to prevent overheating. Dr. Lisa Zhang at NASA's Goddard Space Flight Center had been analyzing the thermal data using techniques developed for studying planetary atmospheres. What she found were temperature gradients that could only be maintained through active thermal regulation systems operating with remarkable efficiency. The energy budgets didn't balance according to any natural process. 3. iAtlas was generating and managing heat flows that required sophisticated engineering and autonomous control systems. The thermal signatures were consistent with an artificial object designed for extended operation in the harsh environment of interplanetary space. But perhaps the most compelling evidence emerged from magnetic field measurements conducted by space-based magnetometers. 3. iAtlas was generating a coherent magnetic dipole field that remained perfectly stable despite the chaotic electromagnetic environment of the solar wind. Natural magnetic fields in asteroids and comets are weak, irregular, and highly variable. They fluctuate randomly as charged particles from the solar wind interact with any residual magnetization in the object's structure. What 3i Atlas displayed was entirely different. The magnetic field was strong, stable, and actively managed. It responded to changes in the interplanetary magnetic environment, with adjustments that maintained optimal orientation and field strength. The control was so precise that the field vectors could be predicted with extraordinary accuracy based on local space weather conditions. Dr. Robert Kim at the Johns Hopkins Applied Physics Laboratory had been studying the magnetic data using models developed for analyzing spacecraft magnetic field interactions. What he found were field management capabilities that exceeded anything achievable with current human technology. The magnetic field was being used for multiple purposes simultaneously. It provided protection from charged particle radiation, created optimal conditions for the mysterious propulsion system, and served as part of the communication array that was broadcasting structured signals across multiple frequency bands. The integration of these functions into a single coherent magnetic field management system demonstrated engineering capabilities that were breathtaking in their sophistication. Natural processes couldn't produce such coordinated electromagnetic behavior under any circumstances. Spectroscopic analysis of the jet emissions continued revealing impossible chemistry. The molecular structures being ejected from 3i Atlas weren't just complex. They were optimized for specific functions that suggested industrial applications rather than natural formation processes. Dr. Catherine Lee at Stanford University had been analyzing the chemical data using techniques developed for studying interstellar molecular clouds. What she found were compound structures that resembled nothing in the natural chemistry catalogue. Fullerene frameworks carrying metallic payloads, organic polymers with precisely controlled molecular weights, and exotic hydrocarbons that would require sophisticated synthesis techniques to produce. The isotopic engineering was becoming more apparent with each analysis. Elements were present in ratios that could only be achieved through deliberate nuclear processing. Rare isotopes were concentrated to levels that suggested advanced separation techniques and enormous energy expenditures. Most remarkably, Some of the detected molecules were identical to compounds being researched in cutting-edge propulsion laboratories on Earth. Exotic fuel combinations, catalytic structures, and energy storage molecules that human scientists had only recently learned to synthesize in microscopic quantities. The probability of such specific molecules forming naturally in interstellar space was vanishingly small. Their presence in the emissions from 3I Atlas suggested either impossible coincidence or direct knowledge of advanced human research. Neither possibility was comfortable to contemplate. The accumulating evidence was painting a picture that challenged fundamental assumptions about humanity's place in the universe. 3I Atlas wasn't just demonstrating advanced technology, it was displaying capabilities that suggested detailed familiarity with human scientific and technological development. The communication protocols embedded in the radio transmissions used mathematical constants and information theory techniques that had been developed on Earth within the past century. The chemical compounds detected in the emissions included structures that appeared in human research literature but had never been observed occurring naturally. Either 3I Atlas represented technology from a civilization that had independently developed identical solutions to the same engineering challenges that human scientists were working on, or it represented something that had been observing and learning from human technological development for an extended period. Both possibilities carried profound implications for how we understood our relationship with whatever intelligence was responsible for 3I Atlas. If it was coincidental parallel development, it suggested that technological evolution followed predictable patterns across different civilizations. If it was deliberate observation and learning, it implied that humanity had been under study by advanced intelligence for decades or longer. The behavioral patterns were becoming more sophisticated as 3I Atlas moved through the outer solar system. The object was adapting its operations to changing environmental conditions with flexibility that suggested advanced artificial intelligence, rather than pre-programmed responses. When cosmic ray flux increased during solar storms, the emission patterns shifted to compensate for additional ionization in the surrounding plasma. When gravitational perturbations from Jupiter altered the local space environment, the navigation system made corresponding adjustments to maintain optimal trajectory. When radio interference from Earth-based transmitters created communication challenges, the broadcast protocols adapted to avoid frequency conflicts. This wasn't pre-programmed behavior following predetermined algorithms. This was dynamic adaptation to unpredictable environmental changes, demonstrating decision-making capabilities that suggested genuine artificial intelligence operating autonomously across interstellar distances. The implications were staggering. If 3I Atlas was indeed an artificial intelligence system, it represented the first confirmed detection of machine intelligence beyond Earth. The philosophical and theological implications were as profound as the technological ones. Questions that had been theoretical suddenly became urgent practical concerns. What were the intentions of the intelligence behind 3I Atlas? Why was it revealing its artificial nature so explicitly? What did its presence in our solar system signify for humanity's future? The answers remained elusive, but the questions could no longer be avoided. The evidence had accumulated beyond any reasonable threshold for doubt. 3I Atlas was artificial, sophisticated, and apparently designed to interact with human civilization in ways that we were only beginning to understand. Yet institutional acknowledgement remained frustratingly absent. The very organizations that should have been leading the investigation were instead focusing their efforts on managing and controlling information flow. The greatest discovery in human history was being treated as a public relations challenge rather than a scientific opportunity. The situation had reached a critical juncture. Independent researchers were building an overwhelming case that would eventually force official recognition, regardless of bureaucratic resistance. The evidence was too extensive, too well documented, and too consistently anomalous to suppress indefinitely. But time was working against discovery. 3I Atlas was moving steadily toward the outer boundaries of the solar system, approaching the point where detailed observation would become impossible. Each day of institutional delay was a lost opportunity to understand what might be humanity's first confirmed encounter with artificial intelligence from beyond Earth. The window for meaningful interaction was closing rapidly. Soon, 3I Atlas would disappear into the interstellar void, carrying its secrets beyond human reach. Whether we would have the wisdom to engage with this unprecedented opportunity or allow it to slip away through bureaucratic inaction remained to be seen. The choice was still ours to make, but the time for making it was running out with each passing day. The greatest discovery in human history was literally moving away from us, and our response would define how future generations judged our readiness to join the cosmic community that 3i Atlas represented. As December approached, the scientific world found itself grappling with a reality that no amount of institutional denial could suppress. The evidence surrounding 3i Atlas had reached a tipping point where even the most conservative researchers were privately acknowledging what the data had been screaming for weeks. This wasn't just an unusual interstellar visitor. This was something that operated according to principles that challenged our fundamental understanding of what was possible in the cosmos. The breakthrough came from an unexpected source. Dr. Elena Vasquez, a graduate student at the Universidad de Chile, had been conducting routine observations with a modest ground-based telescope as part of her doctoral research on interstellar objects. What she discovered would force the astronomical establishment to confront truths they had been desperately trying to avoid. Working with equipment that was primitive compared to the sophisticated instruments being used by major observatories, Vasquez had been taking long-exposure photographs of 3i Atlas every clear night since mid-November. Her goal was simple: document the fading of the object as it moved away from the Sun, providing data for her thesis on the decay characteristics of interstellar comet activity. But 3i Atlas refused to follow the script. Instead of the steady dimming expected from a natural comet receding from solar heating, Vasquez observed something that made her question her own measurements repeatedly. The object was brightening in specific wavelengths while dimming in others, creating spectral shifts that suggested active filtering of reflected sunlight. When she finally trusted her data enough to share it with her advisor, the implications became impossible to ignore. 3i Atlas was selectively manipulating its optical properties in real time, demonstrating control over electromagnetic interactions that no natural process could explain. The discovery sparked a cascade of revelations as other researchers began re-examining their own data with fresh perspectives. What had been dismissed as measurement uncertainty or instrumental artifacts suddenly revealed themselves as genuine anomalies that pointed toward the same disturbing conclusion. Dr. Thomas Anderson at the Royal Greenwich Observatory had been tracking minute changes in 3i Atlas's radio emissions, using techniques developed for studying pulsar timing variations. His data showed periodic modulations that occurred with clockwork precision every 18 hours and 47 minutes. The timing was so exact that it could be used to calibrate atomic clocks. But the most remarkable aspect wasn't the precision of the timing. It was the fact that the modulation period was gradually decreasing, at a rate that corresponded exactly to the optimal adjustment schedule for maintaining communication coherence as the object moved away from Earth. Natural processes don't optimize themselves for communication efficiency with distant observers. The systematic adjustment of broadcast parameters to maintain signal quality across increasing distances was characteristic of advanced communication systems designed for extended operation across interstellar ranges. Meanwhile, gravitational wave researchers were detecting patterns that transformed their understanding of what 3i Atlas was actually doing. The subtle space-time disturbances weren't random gravitational noise. They were structured emissions that carried information encoded in gravitational wave modulations. Dr. Rachel Kim at the Advanced LIGO facility had been analyzing the gravitational signatures using pattern recognition algorithms originally developed for detecting black hole merger events. When applied to the 3i Atlas data, these algorithms revealed mathematical structures embedded within the gravitational wave emissions. The patterns weren't random fluctuations in space-time curvature. They were deliberately modulated gravitational signals carrying information in binary code sequences. The discovery represented the first confirmed detection of gravitational wave communication, demonstrating technology that was centuries ahead of human capabilities. The energy requirements for generating structured gravitational waves were staggering. Creating detectable modulations in spacetime curvature required the controlled manipulation of enormous masses at relativistic speeds. For an object the estimated size of 3i Atlas to accomplish this would require mastery of physics that human science was only beginning to theorize about. But perhaps the most unsettling discovery came from chemical analysis of the interplanetary medium surrounding 3i Atlas. Space-based spectrometers were detecting molecular structures that shouldn't exist in the vacuum of space. complex organic compounds that were being actively synthesized and released by the object. Dr. Jennifer Walsh at the European Space Agency had been monitoring changes in the local chemical environment around 3I Atlas, using instruments designed for studying comet coma composition. What she found violated every principle of interplanetary chemistry. The object was manufacturing complex molecules in real time, creating chemical structures that would require sophisticated industrial processes to produce on Earth. Fullerene cages carrying metallic payloads, organic polymers with precisely controlled molecular weights, and exotic chemical compounds that appeared in cutting-edge research literature but had never been observed occurring naturally. The manufacturing process was extraordinarily sophisticated. Raw materials were being extracted from the solar wind and cosmic ray interactions, processed through unknown chemical pathways, and assembled into finished products that were then selectively released into the surrounding space. Most remarkably, some of the manufactured compounds were identical to experimental propulsion fuels being researched in classified aerospace programs. The molecular structures were so specific, so precisely optimized for particular applications, that coincidental formation was statistically impossible. The implications were profound and disturbing. Either 3I Atlas represented technology from a civilization that had independently developed identical solutions to the same engineering challenges human scientists were working on, or it had been observing and analyzing human technological development with extraordinary precision. Both possibilities carried uncomfortable implications for humanity's relationship with whatever intelligence was responsible for 3I Atlas. The object wasn't just demonstrating advanced technology. It was displaying detailed knowledge of human scientific and technological capabilities. The behavioral adaptations were becoming more sophisticated with each passing day. 3I Atlas was responding to changes in the space environment with flexibility that suggested advanced artificial intelligence operating autonomously across interstellar distances. When solar storm activity increased cosmic ray flux in the outer solar system, the object's emission patterns shifted to compensate for additional ionization effects. When gravitational perturbations from Jupiter altered local space conditions, the navigation system made corresponding adjustments to maintain optimal trajectory parameters. Most remarkably, when Earth-based radio telescopes changed their observation frequencies to avoid interference, 3I Atlas adapted its communication protocols to match the new parameters. The response time was measured in minutes, suggesting real-time monitoring and adaptation capabilities that exceeded human technological achievements. This wasn't pre-programmed behavior following predetermined algorithms. This was dynamic problem-solving in response to unpredictable environmental changes, demonstrating decision-making capabilities that suggested genuine machine intelligence operating with remarkable autonomy. The discovery forced researchers to confront questions that had been purely theoretical just months earlier. What were the intentions of the intelligence behind 3I Atlas? Why was it revealing its artificial nature so explicitly after initially appearing to be a natural comet? What did its presence in our solar system signify for humanity's future? The answers remained frustratingly elusive, but the questions could no longer be avoided. The evidence had accumulated beyond any reasonable threshold for denial. 3I Atlas was artificial, sophisticated, and apparently designed to interact with human observers in ways that we were only beginning to understand. As 3I Atlas continues its journey toward the outer reaches of our solar system, growing dimmer with each passing day, we're left with more questions than answers. The evidence is overwhelming, the anomalies undeniable, yet NASA's silence persists. Those crucial high-resolution images remain locked away. They're secrets known only to a select few who have chosen institutional protocol over scientific transparency. Whether we're witnessing the greatest discovery in human history or an elaborate cosmic coincidence, one thing is certain. 3I Atlas has forever changed how we view our place in the universe. The window for understanding is closing rapidly, and with it, perhaps our best chance to answer the most profound question of all: are we truly alone? The choice of how we respond to this unprecedented visitor will define us as a species and determine whether future generations will remember this moment as humanity's first contact with intelligence beyond Earth, or as the opportunity we let slip away into the cosmic dark.